Hi guys, hope all of us are doing fine. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. Before you proceed, I kind of like to request our members to subscribe, engage us in the comment section and also ring that notification bell for various updates on our topics of discussion. Now in this case, I'll be putting a link of similar videos in our description box of this specific video, and that's going to form a range of other topics of discussion which are going to be of interest for us. Now, in today's discussion, I'm going to look at the variance, and basically this is going to form a second bit of the variance from the first video I've done on the concept of population variance, and therefore we're going to see the difference between the population variance and the sample variance in this particular case. Now, we had looked at the concept of basically the concept of population, which we had defined from our introductory videos. And basically, we had stated that basically for our population, this consists of all possible observations of a specified characteristic of interest, and that's going to form a basis for our discussion. Now, in this case, a sample basically formed a subset of this specific population, which is going to represent these particular characteristics of the whole population. And this one can be, of course, as done using the sampling technique, which we had mentioned in our previous video. And in this case, from our introductory part of the concept of variance on the population, we have decided that we are going to obtain this population variance by dividing the variation by a number of values of that particular population. And we had obtained a general formula for representing this one using a division of the total number of all the total values in a population by the square of this specific variations given in terms of this particular representation. And in this case, I mentioned that basically this I is going to represent values of 1 to the total number of values in that particular population, and therefore that one represented a population variance for a set of data, which of course is going to be ungrouped or rather general case. Now, for our frequency distribution, we had said that we are going to obtain this population or rather population variance by having this specific representation considering the concept of those number of classes, and therefore we are going to have this one given as a general formula of this particular representation. And we said in this case the I is going to represent values over 1, 2 to the total number of classes given in that specific representation. So this one created for us a difference between the population variance for general data and the frequency distribution given as such. Now, in this particular discussion, for now, we are going to look at the concept of the sample variance. And we said that in some cases, we're going to see that the particular value of interest that we're going to obtain is not the same as the parameter. And of course, we said that the concept of a parameter basically represents a characteristic in a particular population. And therefore, we are going to see that a particular value that is going to be obtained is not going to be the same as a parameter. And therefore, we are going to look for a way in which we can form this specific relationship between the population variance and the sample variance. Now, in a sense, we are going to obtain the sample variance by having this specific set of the sum of the squares of the deviations divided by a number of values by less than 1. In this case, I'm going to, of course, perform a specific rearrangement of this specific formula for the population variance by subtracting 1 from the total number of course, the values which have been given for that specific population, and that's going to give me a concept for the sample variance in that particular case. So therefore, I'm going to have to do an adjustment for this specific formula for population variance in order to derive this particular concept of the sample variance. Now, the sample variance is represented using this specific symbol that I'm going to give us that. So therefore, for me to obtain the sample variance, I'm going to less 1 from this total number of values of our population, and therefore I'm going to have this one given as a summation of the deviations given from that specific set of data from the mean. Therefore, that's going to be represented as such. So therefore, the values of I are going to represent 1 to a particular number which I've given in terms of n, which basically is going to represent the numbers of observation given in that. So we're going to consider this particular case for a raw data and frequency distribution, whereby we're going to see that we can have a variation of this sample frequency using the general population, the general raw data given as such. And for our frequency distribution, therefore, we are going to consider the case of a sample variance given in terms of 1 over n minus 1. And then we shall have the summation of this one given considering the frequency given as such. So this is going to be given in terms of that specific representation, whereby we see that for our frequency distribution, the I is going to represent specific number, that one from 1 to a specific number of classes given as such. Now we can also have various variations of this specific formula, or a summary form of these two specific formula for frequency distribution and the raw data given in a specific format. But basically this is going to be the general representation for the first case for raw data, and the lower part is going to form our second set of that specific representation. Now in some cases we're going to come across this particular case for the sample variance represented in a form of the summation from 1 to n given as such, and of course this is going to be the square of the values, of course, of that particular average given as such, and this is going to constitute the number of observations. So in this case there's a difference between the first one which we have given and this one, in a way that this is going to constitute this specific product of the averages times the number of observations given as such, and this is going to be divided by n minus 1. So this is going to form a representation for raw data, and of course that's going to be still representing the sample variation. Now if we consider the frequency distribution, then therefore we are going to have an inclusion of the concept of classes, whereby we are going to have this one changed. So this is going to be a representation for raw data, but for our frequency distribution we are going to have to change this one to the number of classes given as such. We are going to include the concept of a frequency given in that particular case, and this is going to be representing therefore the sample variance of a frequency distribution given as such. So we're going to come across this basic formula for the population and sample variance in our various discussions, and in case we come across perhaps a problem set which requires us to make an application of this particular formula, then therefore I'll be making reference of these particular videos to assist us doing the same. So that is it for now, guys. Kindly check our description boxes for various links of other videos which are going to be similar to these specific topics under discussion. So that is it for now, guys. Bye, God bless you. Catch us in our next video.